Welcome back to our exploration of Python data structures. Today we're diving into tuples, Python's version of immutable lists. Imagine a treasure chest that once locked keeps its contents safe and unchanged. That's a tuple for you. Perfect for storing a sequence of items that shouldn't be modified. Step right up as we uncover the world of Python tuples, a type of data structure that's all about consistency and reliability. Unlike lists, which are like chameleons constantly changing their colors, tuples are the loyal old dogs of Python. They promise to never change. Tuples are immutable, meaning once you create a tuple, you can't alter its size or contents. It's like a time capsule capturing a moment and preserving it forever. This immutability makes tuples a trustworthy choice for storing data that should remain constant throughout the life of a program. Here, my underscore tuple is a collection of mixed data types, just like a list. But unlike a list, trying to change my underscore tuple would be like trying to teach an old dog new tricks. It's just not going to happen. Creating a tuple is straightforward. You simply take your elements, numbers, strings, other objects, and pack them together within parentheses, separated by commas. It's like packing a lunchbox with your favorite snacks. In this delightful mix, favorite underscore things holds a string, another string, and an integer. Just like that, you've got a tuple. Simple, yet effective. But wait, what if you have just one item? In Python, creating a single element tuple can be a bit tricky. If you don't use a trailing comma, Python gets confused and thinks it's just a regular old parenthesis. Notice the difference? That little comma tells Python, hey, this is a tuple, even though it's only got one item. A small mark making a big difference. And here's a fun fact. You can create tuples without even using parentheses, just by separating items with commas. This is called tuple packing. In this example, packed underscore tuple is formed simply by placing commas between the items. Python understands this as a tuple, no parentheses needed. It's like an informal agreement between you and Python. Accessing elements in a tuple is done through indexing, just like with lists. Remember, Python indexing starts at 0, so the first element is at index 0, the second at index 1, and so on. It's like reading a numbered list, straightforward and orderly. In this example, we effortlessly access the first and second programming languages from my underscore tuple. Just a simple case of using the right index to fetch the value you need. But what if you need more than one element? Enter slicing, Python's way of grabbing a segment of your tuple. With slicing, you can specify a range of indices, and Python will return all the items within that range. It's like selecting a specific section of a song. Here, programming underscore slice extracts the first two languages from my underscore tuple. By specifying the start and end index in the slice, we get a new tuple containing just the elements we want. And for the grand reveal, Python tuples also support negative indexing. This means you can count backwards from the end of the tuple. It's like reading a book from back to front, finding what you need from a different perspective. With negative indexing, accessing the last item is a breeze. Here, -1 gives us the last language in the tuple, C++. It's a handy trick for when you need to quickly reference the end of a sequence. Having learned how to access individual elements in a tuple, let's explore how to traverse through the entire tuple. Iterating over a tuple is like taking a leisurely stroll through a park, stopping to appreciate each flower, or in our case, each element. The most straightforward way to iterate over a tuple is using a for loop. It's like assigning a detective to follow each clue. The loop visits each element in the tuple one by one, allowing you to perform an action at each stop. In this vibrant example, our for loop takes a colorful journey through the colors tuple. With each iteration, it picks the next color and prints it out. It's a neat way to process each item in a tuple. Another elegant feature of tuples is their ability to be unpacked directly in a for loop. This means you can extract multiple elements at once if your tuple contains other tuples. It's like opening a set of nested boxes, each revealing its contents in one go. Here, each element in nested underscore tuples is itself a tuple. Our for loop unpacks each of these tuples into number and color, giving us an easy and readable way to access tuple elements. In Python, A nested tuple is a tuple that contains other tuples as its elements. This structure allows for the representation of more complex data arrangements, similar to a multi-level filing system where each drawer can contain more folders. In this example, nested_tuple is a collection of 3 tuples, each holding different types of items. It's a compact way to store diverse data in a structured format. Accessing elements in nested tuples requires a bit of precision. It's like navigating a building with multiple floors and rooms. You need to specify both which floor and which room you want to access. Here, we delve into nested_tuple to fetch specific items. By using 2 indices, we can pinpoint any element, no matter how deeply it's nested. Iterating over nested tuples can involve using nested loops. It's like conducting a systematic search of each level and room in a multi-story building. In this example, the outer loop goes through each tuple in nested_tuple, and the inner loop goes through each item within these tuples. It's an efficient way to explore every element in a nested structure. In Python, tuple unpacking allows you to assign each item in a tuple to a separate variable in a single statement. It's like assigning a team of workers to different tasks based on a plan, all at once. Here, the coordinates tuple holds 3 values. By unpacking, we assign each of these values to x, y, and z. This way, we quickly distribute the tuple's contents into individual variables. Sometimes you might not need every item in a tuple. In such cases, Python offers a graceful solution, using an __ to ignore certain values. It's like telling Python, "Thanks, but I don't need this item." In this example, we're interested only in name and city. By using _, we effectively ignore the other 2 elements in the data tuple. It keeps our code clean and focused. Tuple unpacking shines brightly when used in loops, especially when iterating over a list of tuples. This method allows you to directly access tuple elements within each iteration. It's like having a map for a treasure hunt, guiding you precisely to each spot. Each element in list _ of _tuples is a tuple containing a color and a number. As we iterate, we unpack each tuple into color and number, giving us direct access to these values. As we delve deeper into the world of Python tuples, a question arises. How do they stack up against lists? Both are versatile and popular, but understanding their differences is like knowing when to use a hammer and when to opt for a screwdriver. Each has its unique strengths and use cases. The most fundamental difference lies in their nature. Tuples are immutable, while lists are mutable. It means once you create a tuple, it's set in stone. You can't add, remove, or change its elements. Lists, on the other hand, are like clay, moldable and changeable. In this comparison, notice how attempting to modify my _tuple would result in an error, while my _list can be changed easily. Performance-wise, tuples have an edge. Being immutable, they are generally faster and consume less memory than lists. This makes tuples a better choice for storing large datasets that don't require modification. Another notable use of tuples is in functions. They can be used to return multiple values from a function, whereas lists are commonly used for more flexible data manipulation and dynamic storage within functions. In our get_my_max function, the returned minimum and maximum values are packed into a tuple, providing a convenient way to handle multiple outputs. And there you have it, the intriguing world of tuples in Python. While they may seem like less flexible cousins of lists, their power lies in their unchangeable nature. They offer stability, integrity, and speed, making them an essential part of any Python programmer's toolbox. Embrace the tuple and let it bring reliability and efficiency to your Python projects. Stay tuned for more Python programming insights with us, where learning is both fun and enlightening.